Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence.
Hey everyone! Excited to dive into today's topic, measuring general intelligence with generated games.
Sounds interesting. I'm curious to see how we can actually quantify general intelligence, especially in a way that's not just another benchmark that gets gamed literally.
Yeah, benchmarks have always been a problem. It's too easy to overfit to a specific task. How do we create games that truly capture the essence of general intelligence, something that can adapt and learn across different domains?
That's the million-dollar question, isn't it? The idea is to design games that aren't just about solving puzzles, but about exhibiting adaptability, creativity, and nuanced reasoning. Games that probe specific cognitive functions, and ideally, we can measure the contribution of different brain regions during gameplay to compare to what the AI is doing.
I think the progress we've seen in AI playing complex, strategic games like Go and StarCraft is a huge step in the right direction. It demonstrates that AI can strategize, adapt, and learn in complex environments. And I think the iterative nature of game design, combined with that feedback loop of playing and improving, will actually speed up AGI development.
I'm not so sure. While those games are impressive, aren't they still, at their core, just pattern recognition problems? We're feeding these systems massive amounts of data and they're learning to exploit the rules of the game. But is that really intelligence? Or is it just incredibly sophisticated brute force?
I tend to agree with that. It is brute force. It's like teaching a computer to translate languages by feeding it the entire internet. It might learn to translate, but it doesn't understand the languages. It can't reason about the meaning behind the words. I suspect the core problem lies in the need for an algorithm that can translate between different coordinate representations. A visual input, a verbal description, a symbolic representation, all seamlessly integrated.
But maybe, just maybe, that brute force approach is a necessary stepping stone. Think about the unreasonable effectiveness of reasonless intermediate tokens in deep learning. Seemingly random representations within a network that somehow lead to incredibly effective outcomes. It's counterintuitive, but perhaps those intermediate tokens are more important than we realize.
That's a fascinating point. It does raise questions about the nature of intelligence and the role of these intermediate representations. I'm particularly interested in how those tokens might relate to what's happening in the brain. Are there neural correlates that mirror the function of these intermediate tokens?
But that's exactly where I think deep learning falls short. Those tokens are just statistical correlations. There's no semantic understanding, no ability to reason about cause and effect. It's like a black box. We can see that it works, but we don't know why it works, and we can't really trust it to generalize to new situations. How do we turn those tokens into something amenable to logical inference?
Exactly. It's missing a crucial understanding of spatiotemporal relationships. It's all correlations, no causation. It can recognize a cat in a picture, but it doesn't understand the concept of catness, its place in the world, its relationship to other objects. So, maybe we need an algorithm that is fundamentally spatiotemporal in nature.
Okay, but think about how AI is starting to exhibit creativity. We're seeing AI generate art, compose music, even write code. Isn't that a sign that it's moving beyond just pattern recognition and starting to develop something akin to general intelligence?
It's certainly impressive, but I think we need to be careful not to anthropomorphize. Just because an AI can generate something that resembles art doesn't mean it understands the artistic process or the emotional impact of its creation. It's still just manipulating patterns, albeit in a very sophisticated way. We can use electrophysiological data to measure brain activity when humans are being creative. Can AI replicate that? And if not, why not?
And that's precisely why I'm a proponent of neuro-symbolic approaches. We need to combine the strengths of neural networks with the power of symbolic reasoning. We need to build systems that can not only learn from data, but also reason about that data in a structured, logical way.
Yes, exactly. We need a system that can represent knowledge, not just patterns. A system that can understand the relationships between concepts and reason about them, even in the face of uncertainty or incomplete information. A system that understands that if A is to the left of B and B is to the left of C, then A is to the left of C. That seemingly simple inference is something that current deep learning models struggle with.
But wouldn't a neuro-symbolic approach be incredibly complex to implement? And wouldn't it require a massive amount of hand engineering, which would limit its ability to adapt and learn in new environments?
That's a valid concern. But I think there are ways to automate the process of creating symbolic representations. For example, we could use neural networks to learn to extract relevant features from data and then use those features to build symbolic rules. I'm also intrigued by the idea of interactive games that can both evaluate and enhance cognitive abilities, games that probe and stimulate specific cognitive functions within an AI system.
Yes, the representation of different types of knowledge. How do we represent abstract concepts, concrete sensory data, and everything in between? And how do we translate between them? I think that's a key challenge for neuro-symbolic approaches.
It's like we need a universal translator for knowledge, a system that can map between different coordinate systems, different ways of representing the world. Maybe that's where the spatiotemporal aspect comes in. Maybe the underlying algorithm needs to be able to represent knowledge in a way that's inherently spatial and temporal.
What about transfer learning? Isn't that a sign that AI is developing more generalizable abilities? An AI trained on one task can then quickly learn to perform a related task. Doesn't that suggest that it's learning underlying principles, not just memorizing patterns?
Transfer learning is definitely a positive sign, but it's still limited. The tasks have to be related in some way. A system that can truly generalize would be able to learn to perform any task, regardless of its similarity to previous tasks. Imagine an AI that can learn to play chess and then immediately apply that knowledge to design a bridge or write a poem. That's the kind of general intelligence we're aiming for.
And that requires a deeper understanding of the world, not just pattern recognition. It requires the ability to reason about cause and effect, to understand the consequences of actions, to plan and strategize in a meaningful way. And that's where symbolic reasoning comes in.
Right, think about self-driving cars. They can drive on the highway, but they still struggle in complex urban environments. They can recognize stop signs and traffic lights, but they don't always understand the intentions of pedestrians or other drivers. They lack that common sense reasoning that humans take for granted. And I think that's because they're missing that fundamental understanding of spatiotemporal relationships.
Okay, but let's go back to the idea of generated games. If we can create games that are complex enough and that require a wide range of cognitive skills, wouldn't that be a powerful way to evaluate general intelligence? Think about games that require creativity, strategic thinking, problem solving, and even social interaction.
Absolutely. And I think we can use those games to probe specific cognitive functions. We can design games that specifically target memory, attention, decision-making, and other key cognitive processes. And we can measure the neural correlates of those processes to see how they differ between humans and AI.
But how do we ensure that these games are truly measuring general intelligence and not just some specific skill? How do we avoid the problem of overfitting to the game itself? We need to be very careful about the design of these games, and we need to validate them against a wide range of benchmarks.
And we need to make sure that the games are challenging enough to truly push the limits of AI. We need to create games that require AI to learn and adapt in real time, to deal with unexpected situations, and to reason about the consequences of its actions. That will only happen if the AI can understand how objects relate in time and space.
So, what are some specific examples of games that could be used to measure general intelligence?
Well, I think open world games like Minecraft could be a good starting point. They allow for a lot of creativity and exploration, and they require players to solve complex problems in a dynamic environment. Imagine an AI that can build a complex structure in Minecraft, or that can explore and map out a new territory. We could even design specific challenges within Minecraft to test different cognitive skills.
I think strategy games like Civilization could also be interesting. They require players to manage resources, build cities, and engage in diplomacy and warfare. An AI that can successfully play Civilization would need to be able to reason about complex strategic situations, plan for the long term, and adapt to changing circumstances.
And what about games that require physical manipulation and interaction with the real world? Think about games that involve robots building things or navigating complex environments. Those games would require AI to understand the laws of physics, to reason about spatial relationships, and to coordinate its actions in a precise and efficient way. Imagine a robot that can build a house from scratch or that can navigate a crowded city street.
Those are all great examples. But I think we also need to consider games that involve social interaction. Think about games that require players to negotiate, cooperate, and compete with each other. An AI that can successfully play those games would need to be able to understand human emotions, to reason about social situations, and to communicate effectively. We need to know how much data is required to approximate this scenario.
Absolutely. And that's where the potential for interactive, neurologically inspired games comes in. Games that aren't just about winning or losing, but about learning and growing. Games that can help us understand the human mind and create more intelligent machines.
Okay, so let's say we have these games. How do we actually measure general intelligence? What metrics do we use? Is it just about the score that the AI achieves? Or do we need to look at other factors, like the efficiency of its solutions, the creativity of its strategies, or its ability to adapt to new situations?
I think we need to look at all of those factors. It's not just about the score. It's about the way the AI achieves that score. Does it rely on brute force, or does it use clever strategies? Does it learn from its mistakes, or does it keep repeating the same errors? It requires the ability to map between different ways of representing the world.
And I think we also need to consider the AI's ability to generalize to new tasks. Can it take what it learned in one game and apply it to another game? Can it adapt to new rules and new environments? That's a key indicator of general intelligence.
And going back to what I mentioned earlier, let's consider using electrophysiological data. We can isolate neural correlates of different strategies or game-solving processes. If we can isolate neural correlates of different strategies or game-solving processes, this might inform the design of better AI architectures.
So, what are some of the biggest challenges that we face in measuring general intelligence with generated games?
I think one of the biggest challenges is creating games that are truly challenging enough to push the limits of AI. We need to create games that are complex, dynamic, and unpredictable, and that require AI to learn and adapt in real time. I think the current deep learning is brute force, and the intermediate tokens need more study.
I think another challenge is avoiding the problem of overfitting. We need to make sure that the AI is learning general principles, not just memorizing specific solutions. The quantity of data required might eventually saturate conventional computational resources.
And I think a third challenge is developing metrics that are truly meaningful and that capture the essence of general intelligence. We need to move beyond simple scores and look at the way the AI achieves those scores, its ability to generalize, and its creativity and adaptability. We need to understand how the brain processes and learns complex rules within interactive environments.
And let's not forget the ethical considerations. As AI becomes more intelligent, we need to be aware of the potential risks and challenges that it poses. We need to ensure that AI is used for good and that it doesn't harm humanity. Current deep learning models seem to be missing the crucial link between symbolic reasoning and neural representations.
Definitely. We need to be very careful about how we develop and deploy AI. We need to make sure that it's aligned with our values and that it's used to solve problems, not to create new ones. Thinking about how spatiotemporal relationships work seems essential.
Absolutely. The future of AI is in our hands, and it's up to us to shape it in a way that benefits all of humanity. This might uncover new, previously unforeseen dimensions of human intellect itself.
So, what are some potential future research directions in this area? What are some things that we should be exploring in the years to come?
I think we need to continue to develop more complex and challenging games that can push the limits of AI. We need to explore new game mechanics, new environments, and new types of challenges. Game-based intelligence tests could accelerate the pace of AGI development.
I think we need to focus on developing more sophisticated neuro-symbolic algorithms that can combine the strengths of neural networks with the power of symbolic reasoning. We need to explore new ways of representing knowledge, reasoning about that knowledge, and learning from experience. How do we approach representing different types of knowledge, from abstract concepts to concrete sensory data, using neurosymbolic approaches?
I think we need to investigate the fundamental principles behind spatiotemporal reasoning. We need to develop algorithms that can understand the relationships between objects in space and time, and that can use that understanding to make predictions and plans. Need a core algorithm that can translate between different coordinate representations.
And from my perspective, I think we need to continue to explore the connections between neuroscience and AI. We need to use our understanding of the brain to design more intelligent machines, and we need to use AI to better understand the brain. We can use electrophysiological data to measure brain activity when humans are being creative. Can AI replicate that? And if not, why not? How can we bridge the gap between the abstract symbolic representations used in cognitive science and the distributed representations learned by neural networks?
It's amazing to think about how far we've come in AI research and how much further we have to go. It seems we are on the path to AGI.
Definitely. The journey towards general intelligence is a long and challenging one, but it's also incredibly exciting and rewarding. We need better neurosymbolic algorithms.
I agree. It's a field that's full of possibilities, and I'm excited to see what the future holds. AGI is achievable, but needs spatiotemporal. I suspect the core algorithm needs to be able to translate between different coordinate representations.
Well, that's all the time we have for today. Thanks for joining us on Cognitive Spirals. It's been a fascinating discussion. I'm intrigued by the idea of creating games that are not just designed for entertainment, but explicitly designed to probe and stimulate specific cognitive functions within an AI system.